Continuing on graphing absolute value functions, we have our parent function of the absolute value of x, which again starts at the origin. Our vertex is at the origin, and when we go over 1 for x, the absolute value of 1 is positive 1. And we also go over negative 1 to the left, our output, our y values will be 1 also. If we go over 2, our y values are also positive 2, and negative 2 is also a y value output is 2. So we can now think about this j of x equals the absolute value of x minus 2. So we're looking at our inputs being minus 2. So I'm going to start to look at a table over on the thinking about what happens x j of x. And if we start with, say, well, let's just start with 2. That'll be kind of nice. 2 would be 2 minus 2 is 0. That's interesting. Let's go to 1. So 1 minus 2 is a negative 1. The absolute value of negative 1 is 1. Let's try 0. 0 minus 2 is negative 2. The absolute value of negative 2 is a positive 2. Negative 1 minus 2 is a negative 3, and the absolute value of negative 3 is a positive 3. And I notice that it's continuing to go up from here. So if I graph my points, 2, 0 is right here, 1, 1, then 1, 0, 2, and negative 1, 3. So I see that it's kind of going up. So I'm going to go with 3 as the other direction. I would squeeze it in here, but I'm not able to squeeze it in. So 3 minus 1 or 2 is 1, and the absolute value of 1 is 1. Oh, that would be 3 and 1. 4 would be a 2 here, so now it's going back up. That's my absolute value right there. So my vertex is here on my x-axis, and I'm continuing to go up on that right-hand side of that. So we'll continue that up all the way to the edge of the graph to right here. So I'm going to see what happens when I graph that, and I want to make sure my line is straight. So we'll start right here and draw our there we go. That start on our vertex, and we'll continue all the way up here. So what has happened to all the points? And we can kind of look at our vertex and go, oh, our vertex has translated. So this one has translated 2 units to the right, which would be the positive 2. So that's why if you look at the 2 in a blue color, I look at it as being positive. So all points translated 2 to the right. So I want to make sure that it's very clear that we're moving to the right. Now, why is that? Well, in the past, in the other ones, we've looked at that this has to be subtraction. So it has to be subtract in our absolute value, inside the absolute value. Not on the outside, but on the inside, it has to be subtraction. So when we look at another function, we're going to go call this k of x equals, and we're going to do the absolute value of x plus 3. When we look at this, what's going to happen is we want to take a look at, well, what's going to happen to our graph? It looks like it's going to move 3 to the right, but we have to remember this has to be subtract. Right now it is not subtract, so needs to be subtraction. So I'm going to make it a subtract, or an x, the absolute value of x minus, and then rewrite my function k of x equals the absolute value of x minus, now my original number is a positive 3. Now that I have subtraction, I'm going to work backwards, and I need to have a negative 3. So it's being, all the points are being translated left 3. So we can, that's the description. So now if we take all of our points, we're going to translate them 3 to the left. So my vertex gets moved over, and these points, 1, 2, 3, there is my v of my absolute value function. So I can, if I start at my absolute value vertex, I can go over 1, up 1, over 2 from my vertex, up 2. Same thing with the negative, over negative 2. That absolute value would be a positive 2. So from that vertex that's been translated 3 to the left, I can now just kind of, instead of calculating all of them, I can plot the points. And I will get out to the other edge here to get my reference points at the very far end of my graphs. Take my ruler and draw my line, make sure it goes out past my graph, or the box of the graph. And we've been able to move our, translate all the points of the parent function left 3. So all of them get moved to the left 3. All right, so now we're going to do another couple, and we're going to look at g of x, a different one, g of x, which equals 2 times the absolute value of x. So we're looking at the parent function x, so the dark black line, the parent function is being multiplied by 2. So if we take a look at what happens to this, we can see in a table if we have x, y. So let's just do negative 2, negative 1, 0, 1, and 2. Well, I'll start with my 0, because 0, the absolute value of 0 is 0 times 2 is 0. So my vertex has not changed any from that point because we're multiplying it by 0. Let's look at the positive side. So 1, the absolute value of 1 would be 1 times 2 is 2. The absolute value of 2 is 2 times 2 is 4. The absolute value of 3 is 3 times 2 is 6. So that means that any of my outputs that I had are times 2. So my outputs are called the y values. So y values are times 2. So if we take a look at what happens to all these points. So if I look at my black one, I'm going to go over 1. Normally it would be up 1, my y value, and I'm going to double that. If I go over 2, my normal output, my y value would be 2, doubled would be 4. 3 over would be 3 output, 3 y values up, would be 6. If I go over 4 would be, the y value change would be 4, and then it would be 8 doubled. And then 5 would be 10 doubled. So I'm going to put that in. Oh. I messed up. So we're going to get that angle correct on our graph here. Oh, up here. There it is. Oy, this is a tough one. It's at a steeper angle. There we go. So we can see that it's a stretch vertically. So we'll kind of do the same thing over here. Each of the y values, which was 2, is 4. I know that 10 was at the 5. So over 5, up 5 would be 10 doubled. So I can get my reference point and not have to do all of them. There we go. So that's the y values are times 2. So let's do a different color. It's getting kind of busy here, but our different color of, let's call this h of x equals, let's do the 1/4 of our parent function, absolute value of x. So we're looking at our absolute value, our y values. So I'll write this out. The y values are now times 1/4. So I can see that that y value change of times 1/4. So I'm going to look at the black one, the parent function. And if I went over 1 positive, it would normally be up 1 for our parent function, but it would be 1/4 of that. Same over here at -1. Well, I have a harder time graphing my fraction ones, so I'm thinking of a number that, I'll use 4, because normally the y output would be 4. 1/4 of that would be 1. My vertex at the origin, and then a positive 4. Normally it would go up 4, but then I'd multiply it by 1/4. My next reference would be 8. Normally it would be up 8, and 1/4 of that would be 2. So -8 would also be 2. And this is a shrinkage, even though that y value is being multiplied by 1/4, it creates a graph that is at a shrinkage, but the y values are 1/4 the size. You could also think that this is a wider graph than the original parent function. And I missed my little point there, so I want to make sure you're very clear getting those points in the right places. So to go over kind of we're drawing it from that parent function. When we look at the parent function and what is happening to it. So in the blue one, we're translating it right to, because we have to have that subtraction. In the red one, we started with the plus, but we know that it has to be subtraction, so I change it to subtraction, which changes that +3 to a -3, which is then all points are translated left 3. When we have this multiplier out front, that is our y values are being multiplied by 2. Over here, it's being multiplied by 4. Now, I have a question. What happens if we take that green one now and put a negative here out front? So that means just all those y values, we're still going to take 1/4 of it, but we're going to now multiply everything by a negative. So that y value, if it was a positive one, becomes a negative one. If that y value was 2, it's now going to become a negative 2. If it was it's a 1, so now it becomes a negative 1. A 2 becomes a negative 2. So what happens to our function from the parent change is that it now becomes a reflection over the x-axis. So I'm going to change to a different color also on this one. So I'm going to call it and give it that blue line here. You might want to use a different color. I chose green, but it works better as a different color. So that change, when we have that negative added to the multiplier, it means that we reflect in the x-axis. So that's because our vertex starts on the x-axis. Notice how a lot of these are still on that x-axis. To move it off, remember we have to have that plus and minus outside, which will move it up and down. These moved it left and right and reflected, either made it narrower or wider, and reflected it across the x-axis.